Okay, welcome to the Sandwich200 version 2 belt walkthrough for the replacement for the Core XY kinematics with the unnamed plotter arrangement that was brought prominent to attention by Rich Rap with the Sly 3DR printer. The previous video I just did a walkthrough of the parts, but this time what I've done, as you can see in the darker colours, is I've put in a representation of the belt using a Python class which actually adds up the belt as you go along. So and I've moved the carriage into the middle. I just want to take you through. Basically, the point of doing this is that I got a 3 meter belt. I cut it in half. The belts have to be under 1.5 meters each. Anything over that, and I'd be screwed. So, although the Python classes have the ability to put in arcs, I haven't yet coded it up. But instead I've done a hand calculation. You can see the tiny mouse I pointed out around here. The total round all of the bearings is 50 millimeters approximately. So because they've got 2 bearings, it's pi diameter, 6 bearings each, it's pi times diameter. So 16 millimeter diameter, 2 times 16 is 32. Yes, so that's what you've got to add on. It's actually about 50, something like that, but that's fine. Okay, so let's walk you through the path on these 2 belts. Mostly this is for my own sanity and checking. All right, so that one goes that way. So the X belt starts down here. I'm sorry, the mouse isn't very big. This is an extremely high resolution screen. Starts down. I'll move it into the center of the center of the screen. So went way off. Okay, so starts there, goes to this bearing here, turns right, goes up to this bearing which is on the carriage, comes back 90 degrees, then goes back into the X end, turns right, turns through a rather odd angle here, just to get, now this is a GT216, so the more of an angle you can get on here the better. So I've made it roughly 180, it's about 165 degrees, something like that. If I look at the Python code somewhere, minus 20, can't be bothered, 145, whatever. Okay, goes to the second bearing, then goes up all the way to this idler here, which I previously had in the wrong position, so it's extremely good that I did this exercise. That bearing was just over there previously. So waggle. Okay, over to here, right angle on the, again on the X end, back down to the carriage. Let me rotate that for you. There, you can see we're now sort of looking at an angle down, sort of like this way. Back up again. Let me rotate it back again. The thing, and back, and finally round to there where there will be a variable stop, so you can change. We can change the tension in the belt, sort of the thing. All right, so that's that one. All right, the other belt. It's actually really hard to see. It starts. Oh God, where is it? That red line, it's in there. Starts there, and it's that red line there. This wall on that motor is going, will be moved back by 4 millimeters, I think it is 4 millimeters, so that we'll have the motor there and there'll be a hole in and blah blah blah, etc., etc., all that sort of stuff. So it goes up there. Let me turn it through 90 degrees. The thing turns right on there, goes up to that one, comes back, goes round, goes to this bearing here. Let me just move that to the center. I keep moving the camera whilst instead of this camera instead of the thing. Okay, alright, and then it goes that weird dog leg on there. Comes out and the lower bit down there, right, then goes straight down at the lower level, just missing the back of that. Ooh, does it? Let me check. Ooh, I don't think that. Ooh, it's really tight. Yeah, it does. It misses it by 1 millimeter. Good God. I'm going to have to alter that because the vibration on that belt will stand up hitting that. Yeah. I've actually got enough room to be able to do that, so what I might do instead is just move the bearings over a tiny bit. Then it goes onto this idler down here, this idler bearing, then into that one, back round again, and finally hits the end there. Well, though again, I will decide which of those. Probably this one over here will be the fixed one because it's so inconvenient to get to, and that one will be the belt tensioner point. And the lengths of those are 1332 millimeters and 1374 millimeters. That's excluding the extra 50 millimeters for the going around the bearings themselves. 2 times pi times 16. 2 times pi times 16 millimeters diameter around the bearings. So yeah. It's ridiculously tight. It's very, very close. So I think on the one belt we've got like 25 millimeters to spare, which is that much. Oh, good grief. The one thing that has not been noticed by anybody else in the community is that this arrangement, because you've got the pulley arrangement on here, you actually get an automatic 2-to-1 gearing ratio out of the thing. So if you were to use GT220s, you would still be twice the accuracy, twice the resolution that you would normally get for a thing. And by using GT216s, that's 2.5 times, isn't it? 20 over 16, yes, times so 1.5 over they're roughly whatever times 2, yeah, 3 times better than a standard, even a Core XY or anything. So in combination with using the 0.9 degree stepper motors, you get a lot. It's a big advantage. Yeah, can see there those. I'm just gonna have to live with that, the fact that those are offset against on different levels. You can see that it's pulling there, and this one is pulling at the bottom, so that's top and that's bottom. It's just, you know, if I want to do this any other way, it's going to have to be an extra 50 millimeters on the length and the width. That means total redesign, basically. So we've got this, as I mentioned in the previous video, we've got this sort of stacked, it's higher up. Normally what you would do is let thing. Right, this belt will be at that level, and the other belt will be there, so they will be the other way round. And where are you? That one will be on the other side of this cross member, and that one would definitely be on the other side of that cross member. I just haven't got the space to do it, so it's had to go above it, which means it can't, because it can't go there. This is supposed to be has to be bigger. Oh. Welcome to 3D design. So yeah, with great relief, I am pleased to be able to announce that I've managed to keep both belts down to a 1.5 meter length, and I can now have a big sigh of relief, celebrate, and actually go ahead and maybe even start printing out these pieces, because I'm very reasonably confident. I've got a couple of modifications, but reasonably confident with them. I've got to put the idler things on the corners, and then redo these things, add some support structures on here, sort these things out, and we're done. I can redo try this out. Yeah. Thank you very much.